Just kidding. Lo siento. Oops. Matching number 4, C. Matching number 6, B. Number 14, isn't that a plug and chug to your calculator? Whoa, why did the answer key do the weird, wait, what formula is this going from one base to another? So why'd they use the change of base formula? For the poor little yellow button calculator people. So it works, but whether you use the cool log base option in the math menu or whether you divide a common log, natural log, which maybe it's faster to do this if you remember it than going to the math menu. And anyway, negative 3.823. Did you guys properly expand number 16? And realize that you can simplify 4 to be 2 squared, aka a logarithm is a power, 2 times 2 is 4? Or log base 2 of 2 is 1, or log base 2 of 2 squared is 2. Either way you get 4. Can't simplify him though, because 2 and 3, I can't make 3 match or be a base of 2 nicely or evenly. I can say what it is approximately. 3 is in between 2 and 4, in between 2 to the 1 and 2 to the 2, so it's somewhere between 1 and 2. I'm guessing 1.5-ish. I don't think it's perfectly that, but it's an approximate. Did you guys expand properly by subtracting? Seeing that ln of e, hey, log base e of e, they're inverses, it's just 2. Ew, I don't like how they wrote that. Did anybody write that a better way? How'd you write it, Sam? I totally agree. Why is this gross? Is that ln of 4? Or is it, no, put the negative 2 in front. Put the negative 2 in front. Be better than the book. Ooh, that sounds good. Did you guys get 3/4? It's e to the 3/4 power. Ln of e undoes. 46, you're expanding. 54, you're expanding. 76, you're condensing. Let me give you a second. 46, you're expanding. 54, you're expanding. Thank you. 76, you're condensing. And you can only condense because all the bases are match. All the bases are alike. Otherwise, we'd be in trouble. But that's going to be an x cubed, a y to the 4th, a z to the 4th. He's on top, he's on top, he's on bottom. Dun, 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 dun. Oh, that's the last one. All right, cool kids. Questions on evens or odds? Questions on odds or evens? Yeah. 57, what else? Anything else? Yeah. 79, what else, Gavin? Okay, let's start with 54 because so far he's the earliest. Then we'll go to 57, then we'll go to 79 and see if we're doing all right. So number 54, directions as I'm taking a picture. Use the properties to express, I think, basically expand, right? Yeah. Do you guys agree with that? And how do I know it's basically expand? Guys, look at all of these problems in this entire section. Don't even look at the sum difference. Okay, maybe that would help also. But look at all the logarithms. What's true? How many logs are there per problem? 1. So you're expanding. Okay, number 54. It was 54, right, Gavin? Okay. Number 54. I see a times, I see a divide, and I see a square root. How about you guys? I see a times, I see a divide, I see a square root. So the times, first of all, between this guy and this guy, you can think of using the product property of x, y. Now I know it's kind of awkward because there are x's and y's in here. But when I have log, help me out guys, was that a 2? Okay. Log base 2, whenever I have a product of 2 expressions, I split it into an addition of 2 separate logs. Anybody know why or how I'm rewriting that radical? I'm not done yet. Okay, I'm rewriting the square root to be what power? Good. Now, Gavin, I can see powers, so my next, I can't do the division yet. That's illegal. I need to deal with PEMDAS. I need to deal with the exponents next. So I'm going to go and bring down that 4 using the power property. Bring down the 1/2, Now, if you can do a couple things at once, why am I putting a subtraction in at the same time? And why do I have parentheses? The square root was over the whole shebang. So I'm going to do the subtraction because of the quotient property. I bring down the 1/2, but it needs to be to all the pieces because the radical was around everything. Was around the y and was around the, now I could write z cubed, but what's going to happen to that 3? It's going to change because of the power property and go where? Down in front. Good. Down in front. So I could go ahead and just put a -3 and move it down. My guess is, and I think we just looked at number 54. Can you guys check how you graded it? Did they distribute the 1/2 in? Okay. So then they just went ahead and finished it off to be, I think the direction said a sum or difference, so they didn't want this multiplication, the parentheses here. They just wanted it as addition or subtraction. So the 1/2 can go to this guy. And the 1/2 multiplied by 3, 3 over 1 times 1 over 2 is 3 over 2. I don't know why I almost said bless you to someone dropping a pencil pouch. I was like, bless. Okay. Is that okay, bud? Yeah. Yeah. Because they're all log-based 2's from the beginning. My z's, I put a little line through to distinguish it from 2's. Okay, 57 was the next one. He was an odd, so you guys were able to check Calc Chat last night, so he's still, or he must be a little tricky. Ooh, yeah, there's a lot going on. What's the big picture of this guy? What do I have to deal with first? What do I have to do first? The 4th root. Why? Because he's trapping everybody. So the very, very, very first thing I would do is I would rewrite all of this. Oops, no. Sorry. Just rewrite. To the 1/4 power. Not done, but that's just the first thing. Because that radical is over everybody. So I need to write the entire expression to the 1/4 power. And before I can even deal with this, what do I need to do? Remove the power. Good. Bring down the 1/4 because he's around everybody. So I'm going to have to put a big old bracket and say, okay, whew, I've dealt with the 4th root. Now what's going on inside? Sorry, guys, about the noise. What's going on in the inside? Question. Well, because I'm about to go ham. I'm about to go crazy on this stuff. But I need to make sure the 1/4, because it was over everybody, stays out in front of everybody. So check it. I'm about to go addition. Why am I going to go to addition? Because I have a multiplication in here. But I can't forget that that whole thing, the whole addition, needs a 1/4 in front. So when I go here and I do x cubed and I do x squared plus 3, see, I'm going to have parentheses, and so I put a big old bracket to say, all right, I know there's about to be a mess in here, but 1/4 has to remain outside, okay? Because once again, that radical is over everyone, so that 1/4 has to be to every logarithm. Now I'm going to go ahead and bring the 3 down, but can I bring anything down here? A 1, but can I split this guy up? Can I expand in addition? No, I can only expand products and quotients and powers. I can't expand addition. That's the wrong way. Addition condenses. I have no way to break that up. ln is not a number that gets to multiply. ln is a function that has an argument. There's no way to break up x squared plus 3. So ironically, I just bring down the 3. I have my little 1/4 that's chilling that can now come in, and I'm done. 3/4 ln of x plus 1/4 ln of x squared plus 3. And I'm done. Does that make sense? Dun, 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 dun. Party poopers. And then, Vico, you had number 79? Okay. 79 directions have changed. Now we're going the other direction. Whoa!
Huge.
Well, but it looks a lot like kind of what we just did. Because, Austin, you were asking me about the 1/4 with the bracket, right? Check out number 79. Now it's going the other direction, but what do you see in front of everybody? A 1/3. Okay, that's a messy picture. Hold on. A 1/3 with a bracket. Right? A 1/3 with a bracket. So hold on. A 1/3 with a bracket. There's going to be a big old radical. Now, some of you might be able to jump. How many of you guys found yourselves skipping steps last night? Like doing multiple things all at once. Okay. Let's see, for those of you that were mental mathing it, I'll do them in between steps, but let's see if it makes sense. I'm going to have an ln of a cubed root of something. Does that make sense? Because think, we would have written some mess to a 1/3 power, brought down the 1/3 bracket in front. So that's what's going on. We have a big old 1/3 root, cubed root, a big old 1/3 power. But let's talk about what's going on inside. To be honest, because the cubed root is over everybody, I would have just left him out front and been like, okay, piece by piece. What happens to the 2? Okay, the 2 becomes not a half, squared, right? What happens to the addition? Ooh, I might be having too much fun. Am I having too much fun? ln of, sorry, I jumped to the final answer in my head, and that's not fair to some of you guys. Okay, then the addition is going to turn into multiplication, so x plus 3 squared times x. I think I'm going to eventually put the x in front because he's kind of the little guy. I don't want him to be pushed off to the side, but for right now, I'll leave him there. And then I have a minus. What's going to happen with that minus? Division. So technically, if you need it, we could go ahead and get rid of that guy and come back to him in a second. Please don't shift everything. Aww. Then I can go ahead and do my division. Putting the x in front because he's a poor little guy. And I have my x squared minus 1. Now what's going on around everybody? A 1/3 power, which is a cubed root. So here's my ln. Here's my big old cubed root. Here's my 2 that were positive or being added. And here's my 1 that was negative or being subtracted. Does that make sense? Okay, last call for homework questions. 46. I think he was back one. Aha! Gavin, I bet I know what you did. Can anybody find the common mistake in 46? Yeah. A lot of people without thinking would have written the 4x squared and the y and been like, yay, bring down the 2. Is it 4 or is it 16 in front of the x squared? It's 4. What happens if you bring down the 2? You're saying everyone was squared. But was everyone squared? No. That's the struggle. The 4 is actually to the first power. So the hard thing on this one is there were 2 multiplications. There's a multiplication, that's hard to see, in between the 4 and x squared and in between the x squared and the y. Now there technically are 2 different ways to go. One way is we could have seen this as log of 2x squared. That's legal. Log of y is 2x squared, 4x squared. You could have done that. And you could have brought the 2 down in front of the whole thing. But you still kind of have this addition, or this product that could have been split up. So then it gets kind of complicated, because then we kind of have to think about like a 2 parenthesis or a 2 bracket to distribute when you add. So this way kind of just makes it more complicated. I think what would be easier, because you would have to keep going, I think what would be easier would be seeing each individual piece for what it is. So we have a log of 4, log of x, because the 2 was only a power of the x. And then we have a log of y. Super common mistake. But did that answer it? Yeah, super common mistake. Whenever we see a coefficient, we're like, it's tied. Oh, in logarithms, it's still being multiplied. It's not tied to the variable. It has its own. Yeah. And there's no parentheses making the 4x all be squared.
So if it was just x squared.
Oh, yeah. Bring down the 2 for the x. Does that make sense? Yeah. Or, Gavin, if it looks something like this, where they had grouped something being squared, then you could bring down the 2. But then you'd still have to split this up to be an addition using the product property, and then you'd have to bring the 2 in. It's kind of awkward. But that's the only, when there's parentheses, is the only time we can bring it down in front of the whole thing. Okay, good question. Last call. Going once, going twice. Sold. 3, 4. Let's go have some fun with harder puzzles. Let's go have some fun with harder puzzles. This is just rehashing the problems that you guys made sure you had written down. So you do not need to write this, okay? I'm just giving you guys a couple seconds to transition your notes. Using for that. First of all, did we rewrite that guy? Yeah, how do we rewrite him? 32 we could rewrite as 2 to a power. What property allows us to be like, that's easy? 1-to-1 property. If we can make the bases match, our life is golden. Not golden, but easier. Letter B. Could we rewrite it? Did we rewrite it? Yeah. What did we do? Do you remember? We added, because then if we added, oh, it's just the 1-to-1 property. X equals 3. Done. Right? How about this one? Did we rewrite? Yeah, because we saw the 3 and the 9, and we're like, that's something special. But we said that one's 3 squared. That's a 1/3. How do we make any 1 over into the base that we want? Make it a negative. Good. So we rewrote the 9 to be 3 squared. Rewrote the 1/3 to be 3 to the negative 1, and a power to a power gets to multiply. 1 property. Psh, we like 1-to-1. Did we rewrite D? Okay, 7 is e to the power of 2.71828, 2-ish? No, we didn't rewrite 7 as a power of e. We can't. So what did we do instead? Why did we use natural log? Because it's an inverse. Careful. It undoes. That's what I would say. It undoes. It undoes. Does that make sense? What kinds of functions undo? Inverse. So we used inverse property. So we can't always rewrite them to be the same. I mean, some logarithms are decimals. Most logarithms are decimals. And in those cases, we don't go to the decimal if we can help it. We say ln of 7, dun, 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 dun. Why? Because ln of e to the x, remember, log base e of e, if the log is just a power, that just gives us x, and we are done. How about letter e? You rewrite -3 of something? So if we can't do 1-to-1, how do we get rid of ln? E to the power of. So e to the power of ln, e to the power of -3. Nice thing is, e undoes ln just as well as ln undoes e. Dun, 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 dun. How could you have rewritten this, just sake of argument, another way of writing it? You could have done 1 over e to the positive third. Good. You could have made it 1 over e to the third. Can we rewrite -1 as a log base 10? It's hard. What's easier? What undoes a common log? Not e. That's only for ln. 10. Good. Remember your calculator? Second log button, 10. 10 to the power of. So 10 to the power of 10 to the power of. We get 0.1. Or 1/10. Why? 10 to the power of. 10 undoes common log. X equals 10 to the -1, which is 1/10. Or 0.1 if you guys love decimals. Can we rewrite 4 as log base 3? No. But how do we undo a log base 3? 3 to the power of. That's why we ended with 81. Inverse property. So try to rewrite them with the same base if you can, the same logarithm if you can, the same base exponential function if you can. But if you can't, no big deal. Use the inverse property to undo whatever is trapping the x. Who is trapping the x in D? E. who is trapping the x in E? That's confusing. ln, who is trapping the x in F? Log base 10, who is trapping in G? And that's why we were using the bases as you see. So that's the basics. Let's talk about, real quick, just a little bit of gameplay, just a little bit of strategy. Here's what you should probably be thinking. Here's what you should probably be thinking every time you have an equation with exponential and logarithmic. And remember, those were just basic equations with barely anything going on. They get harder. Think of Sudokus, those were the very easy ones. Think of video game, that was like the very easiest level. So just so we have a good strategy as far as moving forward. Number 1, isolate. Ooh, isolate. This could go into gameplay too. If you're trying to get to the x, you want to isolate him as much as possible. You want to isolate him as much as possible. You want to target in on him. So to target in on him, we're going to use algebra, maybe adding things to the other side, maybe multiplying or dividing things to the other side. We're going to try to isolate the x as much as possible, but if he is trapped in an exponential or a logarithmic, isolating means isolating not just him, but whatever expression he's in. Gavin, you had a question. What's up, bud?
I was just wondering if you noticed this.
No, you don't really need to skip any lines. Thanks for checking, though. We'll do an example right next to this, and then we can kind of measure them up. If you have room in your notes, you could do the example kind of with each of the steps, but that's not required. So number 1, isolate. Take an equation and say, where's the x? What's around the x? Okay, get that alone. Where's the x? What's around the x? Okay, get that alone. As you guys are writing, you can even think with isolate, capture the flag just a little bit. When you first start capture the flag, do you go straight for trying to pull away the goalkeeper? The one defending the flag? No. You try to distract the whole team around it to make the goalkeeper alone. And then you try to distract him to then go in and get the flag. You don't the goalkeeper. You try to frazzle the team that's around trying to protect. Then you go for the goalkeeper. Then you go for the flag. Soccer could be really similar. So in this one, where's the x? Who's around the x? Get rid of everything else. And then, either with the one-to-one property or with the undo, with the inverse property. I didn't actually write him down, but we probably should just based on what we saw on the page before. Use the inverse. Once you have the logarithmic or the exponential alone, use the inverse in order to isolate. Sorry, it looks like 2 E's. That's an S and an E. Sorry, guys. That's an S and an E. Inverse. If you have the x stuck in some sort of log, if you have a logarithmic expression sticking, we could put like some sort of C. But remember, you're going to have to undo. With logarithmic expressions, you're going to have to undo with exponential, b to the power of both sides, for instance. And if you have an exponential expression that you've gotten isolated, for instance, b to the power of, and x is stuck in there, how are we going to undo an exponential expression? With a logarithm. We undo exponentials with logs. We undo logarithmics with exponentials. And that's the basic strategy. Isolate, get the log or the exponential alone. Look to use one-to-one because he's super nice. I mean, he was super easy. Bum, 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 bum. But if we can't use one-to-one, now we have to use the inverse idea. So what happens? Whew. The if we start getting examples. Oh, sorry, still writing? A couple more seconds. Oops, too far. Oh my goodness, where am I? No idea. Way back when. Sorry, it took me to page 1. There you go, Gavin. And a few others that are writing. Sorry, didn't mean to. You're just the first one I saw. Do you think we can see it if I dual page? I think we can. I think we can. Let me make them a little bit bigger. We'll do one at a time. Okay. Letter A. What do you guys think? Can we isolate anymore? No. I have the two exponential expressions as alone as possible. Like there's nothing to really multiply or divide away because these guys are stuck. Okay, how do I unstick them? Should I use the inverse property or should I use one-to-one? But real quick, couldn't you do the inverse and it would do the exact same thing as the one-to-one? What happens if ln is of both sides? Don't you end up with the exact same thing as the one-to-one property? Because doesn't ln undo the e and you're left with just the powers? Does that make sense? So if you mess up by doing the inverse. Either way, one-to-one property. Negative x squared is negative 3x minus 4. If you do the inverse, ln of both sides, same thing, results. Now what? Do you think maybe there should be a step 4? Did we undo? Yeah, we undid. Did we use the one-to-one? Sure, we used the one-to-one, but are we done? Nope. What's the final direction? Solve for x. Aw, stink. It's a quadratic. How do we solve quadratics? Factor. Ooh, to factor. Don't we have to get everything to? Nice. So couldn't I say 0 equals x squared minus 3x minus 4? Dun, 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 dun. We okay? But the key to unlocking the problem for us to solve with the math that we've been practicing in chapters 1 and 2 is getting the exponentials in a sense on and undoing exponentials with logarithms, kind of the one-to-one property. Then it's unlocked to where we can use our math skills to solve. Pause, real quick. There's something that we have to keep an eye out for this section. I'm going to make a little note for it right, let's see, right here. Watch out for extraneous. Have you guys ever heard that word before? Extraneous solutions. Extraneous solutions. Sometimes when you solve, according to the math that's right in front of you, it should work as an answer. But something earlier made it illegal. Watch out for extraneous solutions. And here's what I mean. Check any answers, check any solutions, check with the domain of the OG expression. The original expression. Or the original equation, sorry. The original expression or the original equation. Check with the domain of the original. Now, this isn't always applicable. And here's an example of one that it doesn't apply. I want you guys to go back really quickly to section 3.1, the basics of exponential functions, because that's what this was. It was two exponential functions. Go back to 3.1 in your notes. I want you to look at where we wrote down all the key characteristics of exponential functions. Domain, range, horizontal asymptotes, strictly monotonic. What's the domain of any exponential function? Look at the graph, how left, how right. What's the domain? 3.1. What, Tony? Say it loud and clear. Do you guys see it? Look at the exponential function. Isn't it just the swoop, right? The swoop up one? How left does the swoop go? Negative infinity. How right does the swoop go? Positive infinity. So are there any domain or possible domain problems of exponentials? What's the domain again? All real numbers. So are there any domain problems that could occur in an exponential if the domain is always all real numbers? Any problems? No. No vertical asymptotes, no holes, no breaks. Exponential functions are going to be fine always. So if extraneous only come out, only possibly can occur if there are domain problems, well then forget those guys. Every time, this will be the final answer, no stress. But we always need to go back and check and say, okay, wait a minute. Whew, any domain problems? Nah, they're both exponential. Okay, done. Question, in this one, once we finally solve it, do we have to worry about any domain problems messing me up? Why not? What kind of function is this? And what's the domain of any exponential? All real numbers. Doesn't matter how it's transformed. Exponential functions will always have what kind of domain? Okay, everyone say it all together. Exponential functions always have a domain of? Say it again. Exponential functions always have a domain of? So therefore, exponential functions will never have any domain problems. Exponential functions will never have any what? So therefore, exponential functions will never have extraneous solutions. So therefore, exponential functions will never have. Good. So as soon as it's exponential, be like, I'm good, no stress. Wait a minute, but what function am I not talking about that's kind of a main point of this chapter? Ooh, because logarithmic functions do have domain problems. Could have extraneous solutions. So if you want, it might be a good idea to say, check with domain of original expressions. Extraneous can happen with logarithmic, not exponential. Okay, sorry, I was just warning you because that could come out. That could happen, but only with logarithmic, never exponential. All right, letter B. Go straight to 1 to 1? Nope. Go straight to inverse? Nope. What's the very, very, very first thing you should do? Divide by 3. Get the exponential alone. You can. You can isolate them just a little bit. And what happens when you isolate them just a little bit? 2 to the x equals 3 goes into 4 one time, 3 goes into 12 4 times. Was that right? Can I do 1 to 1? Can I guess? Yeah, 2 cubed is 8. 2 to the 4th is 16. Somewhere around 4-ish, but a little bit less because it's not quite 16. But that doesn't help me. We want to actually solve it exactly. So guys, how do we get the x if there's a 2 to the outside? Log base. Yeah, we could do that. Log base 2 of 2 to the x equals log base 2 of 14. X is equal to log base 2. Is that right? Yes, totally, completely. Totally and completely. Here's a dilemma. Oh, logarithm can't be a negative number. Oh, it's okay, it's fine. Would you guys be able to make it match an answer in the back of the book if it didn't have it written like this, but instead it had ln of 14 over ln of 2? Would you say, like, oh, yeah, I get that. Same thing. Why is it the same thing? Change a base formula. Why on earth would the back of the book change a log base 2 to an ln? In science and higher maths, ln is way nicer than base 2. Not just because of the calculator buttons. So we're going to maybe. Log base 2, yeah, it's perfect. Could you have also been a little creative and instead, could you have said, you know what, actually, I don't have to use a log base 2. any logarithm I put in. Any logarithm I put in. Doesn't cancel that guy out, but it does bring the power down. So maybe they solved a different way that still used logarithm properties, but didn't use inverse. It used instead the power properties. Say, I'm going to put in a logarithm I like, that I'm familiar with, and solve for x that way. Does this way work? Yep. Does that way work? Yep. You just have to remember your change of base formula, and you'll be fine. What I'm talking about right now, guys, is making it match. What I'm talking about right now is making it match. Hey, what's the difference between these guys and these guys? These both included what kind of functions? Exponential. Those ones, oh, what do I have now? Logarithmic, right? Okay, can I use a one-to-one property? No. Is it isolated? Yes. How do I undo ln? Oh, everybody, how do I undo ln? Oh, everybody, how do I undo ln? E to the power. Okay, so what's left when I do e to the power of ln of x? And who's over there? Well, that was easy. Didn't even have to isolate. All I had to do was take e to the power of both sides. Didn't even have to isolate. Ah. Well, this guy's even nicer than that guy was, because what's true? One-to-one property. There's nothing extra, so what can I, either one-to-one property, or what happens if I do 3 to the power of both sides? Even if you forget the one-to-one property and do the inverse property, you'll still end up with the two arguments equal. Now remember, solve for x. All right, all right, all right. Do some algebra, but is it bad? Nope. Now, what did I mean by watch out for logarithms and extraneous solutions? How on earth could this not work? My math was perfect. 3 to the, got it, solve, done. Perfect. Here's the one way it could not work. Because I have logarithms. And logarithms have restricted domains. So I'm going to go back and I'm going to plug in. And I'm going to say, uh-oh, hold on, logarithms, some things don't work. So what I need to check when I plug in is not just if they equal. What I need to check is if they exist. What do I mean by exist? What's not allowed to be in a logarithm? What kinds of arguments, domain problem? What's not allowed to be there? Negatives. Is this a positive? Oh, he's fine. Is this a positive? He's fine. Okay. Whew. All right. Extraneous? No, that's not a problem. Dun, 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 dun. When would it be extraneous? If you plug in and got a negative, that would have been illegal. That's what I call an extraneous solution. He's not. He's fine. He made the logs positive. We're good. This guy. Give me 1 second, Kim. This guy, if I plug in, is e squared a positive number? 2.71828. Is he positive? Oh, so he's fine too. Kim. Doesn't matter. As soon as a negative is inside a logarithm, it's a domain problem. It's illegal. So I'd have to say it doesn't work. And that's exactly what happens for extraneous. They'll probably still both be equal, but the problem is when we did 3 to the power of, we totally ignored logarithms domain restrictions. We just said, oh, forget the log for a bit. But we can't forget him forever because he was the original problem. So, question. What if it gets a little harder? What's the first step? Isolate anybody? What's the second step? If you want to do log base 3, totally fine. If you want to do ln, totally fine. Is it going to be pretty? No. But is it going to be right? Yes. But how would you have to finish? Solve for x, right? And depending on how you solve for x, it might take you a couple extra steps, but long story short, you would end up with 6 minus log base 3 of 5. Wait, what if the directions say approximate to 3 decimal places? What? I have an answer. I know. But what do they want you to do? Put it into decimals, because depending on how you solve the problem, awkward. Depending on how you solve the problem, you could have many different ways of writing this, and you're still right. So what they want is for whatever answer you have, for you to go to decimals so that you can check and make sure, even if it looks different, the answer is the same. Does that make sense? Okay. So when they say decimals, go to your calculator, check the decimal. It better match the back. Even if the form is different, the decimal better match. All right, cool kids, work on this homework for Monday. I'll see you later. To do decimals, yeah. Yeah, to check decimals. Oh, I didn't get to give you a hint on the next one. I'll put a hint in the end of the video, just in case you need to go check it out. Can't do log 2 or log 3. I would just do an ln. Bye. So it doesn't matter. You're welcome. Whew, that was messy. Not impossible, but it's a little messy.